All right, everybody, welcome to a chemical reactions lesson, SHS style. This is Miss Quinn. So today we're going to be talking about chemical reactions and reviewing subscripts, coefficients, the law of conservation of mass, and balancing chemical equations. So right now, I've got some hydrogen and oxygen, and we want to make water out of this process. This is actually what happens in the space shuttle, and I'm gonna let's watch the space shuttle for a little bit. So in the space shuttle, I was actually there to watch this particular launch. This is STS-135. It was the last launch of Atlantis. So in the big orange tank, there is some liquid oxygen and some liquid hydrogen in the big orange tank and the other two. It's solid rocket boosters. It's mostly liquid hydrogen and liquid oxygen. What they do with that is light it on fire. And those guys really want to... Oxygen doesn't really want to be bonded to itself. It would prefer to be bonded with hydrogen, because that's a lower energy state. And all of those, all of that column of smoke you see isn't actually smoke. It's water vapor, because the whole space shuttle is making water from that process. So it takes hydrogen and oxygen. The white ones are hydrogen, red's oxygen, and it's going to make water, H2O. Can it do that? What's with this extra one going on? Since it cannot make, if it only made that, it would be losing a random atom. You cannot lose or gain atoms or mass. You can only change form. So we have this extra oxygen here that is not going to be happy. So it is going to find more hydrogen atoms. And then it's going to react with those hydrogen atoms, just like this one. So we've got our reactants here. And our product here. Remember, the arrow always points to the product. So we started with hydrogen and oxygen, and we're making water. And it didn't work with just one of those, because we didn't have those. So we had to have a second molecule of oxygen in order to make two full molecules of water. So when we do this process, it's called balancing a chemical equation. We have to do it because you cannot create or destroy matter. You can only get it to change form. So we couldn't randomly create two waters here without having those two extra atoms of hydrogen. Oopsies, that goes there. We only have one set of oxygen, and we've got two sets of hydrogen. Okay, how about another example? Here I've got some methane. This is the combustion of methane, where methane is going to react with oxygen in the air to make carbon dioxide and water. And I've got a video of that here too for you. Let's play that.
I've got this balloon that is filled with methane gas. Okay. And I thought it might be fun to maybe have you hold some in your hand and light it on fire.
Yeah, I love to hold fire. I do it all the time. Just kidding, but I will today. So let's try it out.
That's okay. We've got lots of cool things here. So this is just some soapy water.
Okay.
And then I have some water here for you. This is going to protect your hand. Okay.
Wow.
So I'm actually going to have you go ahead and dunk your hand into that water.
This
maybe
water?
Yep, and get it maybe like up on your wrists.
Up on my wrist? Okay.
And what that's going to do is protect you from our flames. And while you're doing that, I'm going to go ahead and start making some bubbles here.
Oh, very cool. Look at you.
All right, now this is methane gas. It's flammable gas, so it's different than our hexane gas. It's actually lighter than air.
Ah.
Okay. So it looks like maybe more. Is that good?
I mean, it looks great, sure.
Okay.
I like bubbles. Yeah.
All right, now what I'd like you to do is take your hand and scoop up as many of those bubbles as you can.
Okay. Ooh.
And just hold your hand straight out in front of you like that. Okay? You ready?
Sure.
You guys ready?
Are we ready?
A column of flame.
Maybe holding
ready?
flames. Yep.
3, 2, 1.
Ooh, that was awesome.
All right, so you can't see the products of this reaction, but you should know that they're there. Hey, where did my oopsies, I don't know how to get out of that. Give me a sec. Hey, you, get out of there. Yay. All right, so we had some methane gas, which was in the bubbles. This one was in the air, and it's going to react to make carbon dioxide and water. As written, if we try and make carbon dioxide and water, we are going to make, well, we got carbon dioxide, but we don't have any water. Why is that? Well, these 2 oxygen are already used up by the carbon dioxide, and there's no oxygen to make the water from, because the law of conservation of mass says that you cannot create or destroy matter, it can only change form. So, we need to balance this equation and actually be able to make water. Because this says we have some water. Yeah, we don't right now. So what if we had these guys? You must always have them in whatever set. Imagine that as a set. You cannot have just one oxygen atom by itself. You cannot do that. It has to come in its set. So if we have another of those, then we can go, okay, this oxygen 1 and oxygen 2. Oxygen 1 can bond to 2 hydrogens, and oxygen 2 can bond to another 2 hydrogens. So what does that really look like? That looks like this when we get it done. So we've got 1 methane. For every 1 molecule of methane, it requires 2 molecules of oxygen to combust to make 1 molecule of carbon dioxide and 2 molecules of water. Okay, so the next one is a question for you of whether or not something obeys the law of conservation of mass. This is your next question. As written, does it obey the law of conservation of mass? Are there atoms being created or destroyed as this reaction is currently written? Or are they being conserved? Is it the same stuff on one side as the other? Your answer should have been no. This is not obeying the law of conservation of mass. We have 2 atoms of hydrogen there, and we have 1, 2, 3. That one's new. We have 1, 2 atoms of nitrogen here, and we only have 1. What happened to the other one? This one definitely does not obey the law of conservation of mass. So let's start out thinking through this in order to balance it. If we are going to have these 2 molecules or 2 atoms of nitrogen within 1 molecule, we're going to be able to make 2 molecules of this. So that's atom 1, that's going to be atom 2. But in order to do that, we've got 1, 2, 3, 4, 5, 6. We need 6 atoms of hydrogen. Now, we cannot just add them by themselves. They have to be in this set. So we're just going to have 3 sets. So if we have 1 of those, we're going to need 3 of those to make 2 ammonias. And that looks here like this. 1 of those, 3 of those, and 2 of those. Okay, this is a picture drawing method of balancing equations, and now we're going to switch to how to do this without the pictures. You're going to have to start counting things in your head and writing them down. So, atoms are not created nor destroyed during chemical reaction. Science know there must be equal numbers of atoms on each side of the equation or reaction. To balance the chemical equation, you must add coefficients in front of the chemical formulas of the equation. You cannot add or subtract subscripts. So when we were over here, let's talk about some vocab real quick. So we've got reactant and product. That is a subscript. That is a coefficient. Reactants are always before the arrow. Products are after the arrow. Arrow points to products, if that helps. Okay, so notice we have the exact same. We've got 4 atoms of this. 2 times 2 is 4. And we've got 2. We could also write a 1 right there. And then 2 times 2 is 1, 2, 3, 4. And 2 times 1 is 2 of those. All right. Moving on. We are going to balance some chemical equations. So here, it says determine the number of atoms. I like to draw a line separating the reactants and products. So I've got 1 atom of magnesium and 2 atoms of oxygen right now. And in the products, I have 1 and 1. Pick an element that is not equal on both sides of the equation. This is step 2. So oxygen is not. So we're going to go with oxygen. Add a coefficient in front of the formula with the element and adjust your counts. So I need to make the product have 2 of those, but that 2 applies to both of those. Now I have 2 oxygen and 2 magnesium. Step 4, continue adding coefficients to get the same number of atoms of each element on each side. So now I've got magnesium. Back to step 2, pick an element that is not equal on both sides. Magnesium isn't. Step 3, add a coefficient. Let's try that. Now I have 2 of those. Step 5, recount and simplify ratios. I will get to that later, but essentially, if you have at least 1 odd coefficient, you're probably good. If everything else is even and you have at least 1 odd coefficient. Odd meaning like a 1, a 3, a 5, or a 7 or something like that. Yeah, that one's good. We are done. Let's try another one. I want you guys to write these down before I start, so you guys can do them with me. Go ahead and pause. Okay. So I've got calcium on this side. Step 1 is to count. So I've got 1 calcium, 2 oxygen. 1 calcium, 1 oxygen. Well, my oxygen's not satisfied. That's step 2. Step 3 is add some coefficients. So I'm going to add a coefficient there. So I have 2 of those and 2 of those. Now back to step 2. That is not satisfied. I'm going to add a coefficient there, adjust my count, Now I'm satisfied. You can either leave these blank or write a 1. It doesn't matter if there's only 1. If it's blank, it's assumed that there's a 1 right there. Okay, next one. We can call that question 1. Question 2. We already did that one. Actually, yeah, I'm going to do it again to show you guys the number method. Okay, so N2, I've got 2 of those, 2 of those, 1 of those, and 3 of those. So both of them aren't satisfied. Let's just pick one. I'm going to start with nitrogen just because it's on top. I've got 2. Let's try 2 of that. That means I have 2 nitrogen, and 2 times 3 is 6. So now my nitrogens are good, but my hydrogens are not. So I need to go, all right, so how many sets of that do I need to make 6? What times 2 is 6? My answer to that is 3. So now 3 times 2 is 6. I've got 6 of those. Those are good. Again, you can either leave the N2 blank or you can put a 1 right there. It doesn't matter. Next, we'll call this question 3. So copper oxide plus carbon is going to make copper plus carbon dioxide. So the copper and carbon are switching places, being attached to the oxygen. I'm going to draw my line separating the products from the reactants. I'm going to count 2 coppers, 1 oxygen, and 1 carbon. I'm going to count 1 copper, 2 oxygens, and 1 carbon. So my carbons are satisfied. There's an equal number of carbons in the products and the reactants. My oxygen and my copper are not. So I know I'm gonna need, actually, let's just do this. If we put 2 there, our coppers are satisfied. Woohoo! Those are satisfied, those are satisfied. We need to do the oxygen. Well, we've got 2 here. So we need 2 over here. So I'm going to put a 2 right there. So now I have 2 oxygen, but remember, that applies to both. So that 2 times 2, that means we have 4 copper. Copper is no longer satisfied. We're going to erase this and put a 4 there. Now we're satisfied. Go back and recount. I've got 4, I'm going to use a different color for this. 4 copper, 4 copper. I've got 2 oxygen, 2 oxygen, 1 carbon, 1 carbon. Okay, we're good. Question number 4. So this is the breakdown of hydrogen peroxide into water and oxygen gas. Again, I'm going to split my reactants and products. I've got H2. I've got 2 of those and 2 of those. Here I've got 2 waters and 1, 2, 3. So anything on this side, you have to add if the oxygen or whatever atom appears in 2 of the products or even 2 of the reactants, you have to count both of them for that side of the equation. So my hydrogens are fine, but my oxygens are weird. My hint here is to take the odd one and double it. This is even. This is even. This one's odd. So we're going to take that one and double it. So 2 times 2 is 4. 2 times 1 is 2 plus those 2. So 2 plus 2. We actually have 4 oxygens on that side now. And then, well, our hydrogens are now not satisfied. Uh-oh. We're going to need 2 of those. That means I've got 4 hydrogens and 4 oxygens. Oh dear, I've got 4 oxygens now. Okay, wait. Haha, guess what, guys? There's 4 oxygens, there's 4 oxygens. Because 2 times 2 is 4, and there's 2 of them in there, 2 of them in there, we're done. So this is actually a 1. Woohoo! Alright. So, our next step. This is, we're going to call this question 5. Okay, so same amount of, same stuff on the right side as the left side. Same stuff in the product as the reactants. If this, instead of saying sodium fluoride, tried to say magnesium chloride plus H2, there's no way you could make sodium, turn sodium plus magnesium fluoride into magnesium chloride and hydrogen gas. You could not. This is alchemy. This is not science. This is not chemistry. So if you ever see anything with weird, like this stuff creating that instead, just know that it will not obey law of conservation of mass, because you are magically creating hydrogen when there was none. You are magically getting rid of sodium, and you cannot do that. Alright, so here we are going to have to create the counts ourselves. I'm going to say always, whatever list you put them in here, put them in the exact same list here, even though they're in different order on the other side. So I've got Na, one of those, Mg, one of those, F2, 2. Na1, Mg1, F1. So it looks like our fluorines are what does not obey the law of conservation of mass. So we're going to start with a 2 right there. That 2, remember, applies to both. So we've got 2 fluorines and 2 sodiums. Ooh, and let's do that. 2 of those. Go back and recount. Tuna. Haha, tuna. Chemist's favorite fish. 2 sodium, 2 sodium. 1 magnesium, 1 magnesium. 2 fluorine, 2 fluorine. Sweet! I want you guys to try this one on your own. Come back and watch the video to see if you did it right. I've got 1 magnesium, 1 hydrogen, 1 chlorine, 1 magnesium, 2 chlorines, and 2 hydrogens. I'm going to need, oopsies, 2 of those. 2 there, 2 of those, go back and recount. 1 magnesium, 2 hydrogen, 2 hydrogen, 2 chlorine, 2 chlorine. Sweet! That's all. And you can leave the magnesium chloride, and the hydrogen blank if you want, or you can put 1s there. It doesn't matter. Alright, again, I want you to try this on your own. Go ahead and pause it and come back in a sec. Chlorine, ClKi. ClKi. 2, 1, 1. 1, 1, 2. I'm going to take the iodine. Let's start with the chlorine. So that applies to both of those. 2 chlorines, 2 potassiums. Now I'm going to do the potassium. Looks like it's next. I put a 2 right there. 2 of those. 2 chlorines, 2 chlorines, 2 potassiums, 2 potassiums, 2 iodines. 2 iodines. Sweet. So that one gets a 1. That one gets a 1. Let's try something a little bit harder. Yeah, I think this one will be harder. Let's find out. Again, pause it. No. it's over. NaHCl. NaHCl. I've got one of those, one of those, one of those. 2 hydrogen, 1 sodium, 1 chlorine. This time I've got a hydrogen problem, so I'm going to put a 2 right there. That 2 applies to both. 2 of those. Then I've got a chlorine problem. I need 2 of those. But that also changes that. Now I've got a sodium problem. I need 2 of those. So the only one that's odd is our hydrogen gas right there. All right, all. I think you've had a wonderful time. Good luck, have fun, and keep learning. Goodbye, y'all.